না জাস্ট ইউটিউবটা আমি লাইভ করে দিচ্ছি, তারপর লিংকটা আপনাদেরকে শেয়ার করে দেবো।
লাইভ হয়েছে, লাইভ।
I have trying this since last 5 minutes. Zoom এর কিছু প্রবলেম স্টার্ট করে দিচ্ছিল না। Now it has started.
It will start at 4 o'clock only. That's why.
Maybe.
It is showing webinar is now streaming live.
Yes.
Yes.
On YouTube.
And now some people have joined. I think 15 people have.
Now it is showing live on YouTube.
Today being Sunday, মাংস ভাতের পরে একটু বোধহয়।
চলো, আমি
So
On people.
everyone able to view my screen now?
Yes.
Yes.
Okay. Good evening, good afternoon, and a warm welcome to everyone here. We have an awesome list of panelists, and the attendees have now joined up. So this is the online engineering seminar for reverse engineering. So will be your host during the webinar. There are a few guidelines which I would like to share with you. So just to keep a note, like all the panelists will be given a 7 minutes time, followed by a short buzzer, so that they will be understanding like the time is there, so that other people can also speak. And during the ongoing speech of the panelist, I would request the other panelists to please kindly keep themselves in mute, so that the noise, background noise can be eliminated. And for the attendees, there are Q&A sessions. If they have any questions, please record this in Q&A session. If any panelists are available, they can reply you over there. Or else what we can do is to open the forum after all the panelists have completed. We can have the question sessions after that as well. And having said that, this webinar is now live on YouTube. The link has been given below. So this is the link. So I will share this link in the chat as well. So that's it. And the next step is our moderator, Mr. Annamda, will present the program schedule to all of us. Thank you. And hope you have a nice webinar today.
Good afternoon and good evening, every attendees and panelists. On behalf of GBS Energy Private Limited and on my personal behalf, I welcome all of you to this seminar. The subject of the seminar is very rare one, reverse engineering. Many people haven't done any seminar on this topic, I believe. Very few seminars, if any, was there on this particular issue. Anyway, I once again welcome everyone, and now I present the program in this is the topic, reverse engineering in industries for hardware and software, a big facilitator for Atmanirbhar Bharat, particularly in COVID situation. Next, the seminar program and speakers list will be presented now. The first will be the introduction by the organizer, Mr. Amitabh Ghosh, who is the director of GBS. He has got very vast experience in steel and power sector. He will first give the introductory lecture, followed by next one, Mr. Niranjan Saha, who was the ex-project director of WTDC. They are the organizers and they will first present about the seminar. Now, next speaker will be Mr. Pritish Kumar Sen. He is the head of INSTAC, Institute of Steel Development and Growth. and he was working in Tata Steel throughout his career. So next speaker will be Mr. Devatosh Nag. He is from Taiwan, is renowned industrialist in Taiwan. The next speaker will be Mr. S. Mahapatro. He is the ex-managing director of WPC. Followed by Mr. Pranab Mukherjee, who was the ex-director of EIL, Engineers India Limited, and followed by Mr. Arunabh Dattagupta, who was working in ISCO Burnpur and having very vast experience in steel sector. The next speaker will be Mr. Somnath Bhattacharya. He is a reputed steel designer with vast experience in steel plant sector. Next speaker will be Mr. Devabrata De, who was the advisor in NWEPDI and ex-director of WBPDC. The next speaker will be Dr. Nitish R. Mandal, ex-professor and head of the Department of Ocean Engineering and Naval Architecture in IIT Kharagpur. The next will be Mr. Saroj Kumar Rana. He was ex-Dastur and BTS and vast experience in engineering and education sector. Followed by Mr. Lalit Tejwani. He is Chief Marketing Officer of Hind Rectifiers Limited. Then Mr. Amitav Ghosh, the organizer, will give his lecture on the topic of the seminar. It will be followed by interactive session and vote of thanks by Mr. Shubir Ranjan Ghosh, ex-head and plant and projects, Haldia Petrochemicals Limited. The whole seminar is hosted by Mr. Amit Kumar Das. He is sitting in UK and his company is in Amitech, India. And myself, Arnav Banerjee, I am the director of Steel Tech. Okay. So now I hand over the mic to Mr. Amitav Ghosh for his introductory address. Please, Mr. Ghosh.
Good afternoon, everybody. On behalf of GBS Energy Private Limited, we welcome all to this seminar titled Reverse Engineering in Industries for Hardware and Software, a big facilitator for Atmanirbhar Bharat, particularly in COVID situation. Now, this process and modality of reverse engineering is generally known to technocrats. This is the fastest and safest mode of engineering for successful execution of work with little or no external help or support. We all know that Japan used this reverse engineering technique long back successfully for revival of economy after Second World War. And in recent past, China had been using this mode aggressively and very successfully for a remarkable exponential growth on a sustained basis. Now we come to the Indian scenario. In India, 60s, 70s, 80s, and also in 90s, Indian technocrats like me, we did a lot of reverse engineering successfully under compulsion because importation was very difficult, almost banned. It was very costly, long delivery schedule, and also that port handling clearance, long time. So we had to do a lot of reverse engineering ourselves. This is scenario one. Now, scenario two is that late 90s and early 21st century came the Chinese aggression of economies. The whole market was captured by China with a lot of products, equipment, system, everything. Their price is very low, delivery schedule fast, and of course, questionable quality assurance. But people started buying it. So this was the scenario. Then we had geopolitical problem with China. So it was decided by the government that we will not import from China and we'll follow Atmanirbhar initiative, which is nothing but Make it India initiative and self-reliant India, what we used to say. This is great. But only one thing is there, this is only possible if with a solid engineering base. Without that, Atmanirbhar Bharat is not possible. So this scenario and subsequently in 2020, we had this unprecedented, unpredictable COVID. 2020, then 2021, March, second wave. And now people are saying third wave is coming, August, September. So nobody knows how many waves will come. Most unpredictable. But I feel, or we feel, that this is an opportunity to grow ourselves. Because it is as if done in First World War and Second World War, because they were under compulsion. And here we are in a warlike situation, absolutely warlike. So in this situation, following up to Atmanirbhar initiatives and taking support from senior citizen technocrats who have wealth of knowledge, techno-commercial knowledge in this subject of reverse engineering, we should move ahead. This is the thing which I wanted to say, that if we do that, then in a short time, we can make a lot of things. And now another thing I must say, that because of the restriction of the movement of goods and people, so there is a possibility that we can get software and engineering from other countries because they may not be in a position to give material. So this is along with our own knowledge, if we combine, that will be also very great. And now I'll just tell you that what is the application area and what is the objectives. Application area is process technology, number one. Number two, product and equipment. Number three is the spares. Number four, that RMU or RLA of existing plants. And fifth is very important. It is the new or diversified business areas in present situation. That is also reverse engineering, I say. That today, a lot of people have lost their jobs and no new areas is found out. We have to find out, technocrats have to find out what is the alternative way so that we can move ahead and take our economy forward. And lastly, most important, it will also allow us to revive the engineering knowledge, which we have actually lost after Chinese economic aggression. We were not doing any engineering. Now it is a time that we should revive our engineering application. And in short, I'll say the objectives. Objectives are cost-effective solution for operation maintenance of existing plant, including restoration of drawings and data bank. Secondly, upgradation and life enhancement of existing process and engineering units. And third, again, identification and initiation of new business areas. So I will now tell you the details of the seminar objectives. Amit, I'll request Amit, please show me that. Yeah, next, please. Amit, next slide, please. Next slide, Amit. Yeah. So this is to review, can you see in full? To review and present cases and use of reverse engineering for maintenance and getting higher life of old assets in defense sector, steel plants, engineering industries, power plants, etc., to achieve the goal of self-reliance at competitive cost. Another thing is to discuss present methodology of reverse engineering and setting up of standards for integrity of redesign of components. Next slide, please. Next slide, please.
It's taking a while.
Next
I've
slide.
done that.
Amit, next slide, please.
It is. I have done the next slide. Point number 3.
Yeah, I got it. Thank you. To discuss application of reverse engineering in software development. Number 4 is to discuss the ethical, legal, and patent issues for application of reverse engineering in India. Number 5, to create mass awareness across decision makers, government machineries, and premium engineering colleges like IIT, NITs, etc. Next. To manufacture indigenous spares and components of imported equipment for core sector industries like steel, aluminum, power, mining, etc., so that we can do the import substitution and savings in foreign exchange. Number 7 is to carry out health check, residual life assessment, study and recommendation for life enhancement of plant and equipment. Next. Number 8 is to create huge opportunities for services and supplies in Indian engineering industries. Particularly, it will have development of MSME sectors who are presently going in very difficult phase in pandemic situation. Number 9 is to create and develop an important role for reputed technical institution or organization towards aforesaid objectives in association with suitable industry partners and also senior citizen technocrats. Next. To create avenues and opportunities to follow Prime Minister's Atmanirbhar Bharat initiative, particularly in COVID situation. And finally, to present a panel of renowned experts from different sectors to interact with participants on our aspects. We have a panel of experts on various engineering subjects: steel, power, shipbuilding, oil, gas and petrochemical, heavy engineering, material handling, shoe and other areas. Thank you very much. I'll now request my colleague Mr. Niranjan Shah to speak on the subject. Mr. Shah is a very reputed man in power industry, and he was the director of West Bengal Power Development Corporation and also director of GBS Energy Private Limited. Mr. Shah, please.
Good afternoon, everybody. First of all, I welcome all panelists and participants for attending this webinar organized by GBS Energy Private Limited Company. In 2017, my friend Amitabh Ghosh, myself, and Sri Obijit Bishoy, a young engineer having vast experience in non-conventional field, we opened this GBS Energy Private Limited Company. The business areas of our company is mainly to support in developing projects or products in core sector areas like thermal, hydel, biomass, solar, wind power plant, and also in material handling, heavy engineering equipment, and last but not the least, electric passenger vessel. We organized one seminar in 2019 on thermal power plant and also on hydel power plant, their performance, etc. And thereafter, we could not arrange any further seminar because of this COVID situation. And we organized two webinars, one in November 2020 on renewable energy sources, and another in January 2021 on steel sector. Today, we have organized this webinar. The topic is reverse engineering in industries for hardware and software. A big facilitator for Atmanirbhar Bharat, particularly in COVID situation. I am not an expert on this subject, so I cannot talk much about this subject. We have some expert panelists here today who can share their knowledge on this subject through their presentation. I only want to share some of my experience that why this reverse engineering is needed in industries, particularly those are 25 to 30 years old and now running with lower capacity and also with lower efficiency. To run this industry smoothly, the reverse engineering is very much needed for replacement of spare parts and equipment. The reasons are that OEM of this old equipment is no longer available in the market at present to supply spare parts or assembly. Number two, drawing and documents of those spare parts or assembly are not available as those are not maintained properly by the owner. Sometimes OEM is also unable or unwilling to provide replacement of these parts as they have discontinued the manufacturing of these parts or equipment. Another most important is the foreign equipment suppliers. They charges very high price for supply of spare parts. So development of local supplier is a must, and for that reason import substitution of spares or equipment is very much necessary. Another most important area where this reverse engineering is very much needed is the renovation and modernization of any particular equipment or plant. The main reason is almost the same, that drawing and documents of the old plants are not available. Owner wants that after completion of R&M, the plant should run further for at least 15 years with higher capacity, 5 to 10%, and also with high efficiency. New or modified equipment are also required to be installed on the old civil foundation, as sometimes the demolition of old foundation may not be possible due to space constraint or due to nearby foundation of other equipment or structure. Another most important area is the control and instrumentation system of the plant, which required to be changed in totality from earlier analog control system to the digital control system. Moreover, the old plants were designed with earlier environmental rules and norms, but after R&M, compliance of present environment rules and norms is one of the must condition. It is really a big challenge to the designer to design these new equipment and install them in the plant on the existing civil foundation. So reverse engineering is very much necessary in industry for hardware and software, for changing parts and equipments, for import substitution, and also in R&M projects to achieve higher capacity with high efficiency and due compliance of present environmental rules and norms. Thank you all. Now I will hand over to Arnav for
Thank you.
further proceeding.
Thank you, Mr. Shaha. I now invite our first uh, speaker today, Mr. Pritish Kumar Sen. Mr. Sen is now head of INSPEC, and he was working with Tata Steel. Now, please take over, Mr. Sen.
Thank you, Arnav. Am I audible?
Yes, you are very much audible.
Thank you, Arnav. Thank you, Mr. Ghosh, Director of GBS Energy. A very good afternoon to all eminent panelists and ladies and gentlemen attending the webinar. At the outset, let me first congratulate GBS Energy for organizing this webinar on a very important topic of reverse engineering, what has just been told by Mr. Saha. In industries for hardware as a software, a big facilitator for Atmanirbhar Bharat, particularly in this COVID situation. This is once again a very apt and important topic, like the one they conducted at the webinar on 22nd of January 21. Some of you who have attended that may recall the topic as an innovative approach to increase the use of steel in building, bridges, flyover, and other suitable areas of infrastructure in a cost-effective manner. This GBS Energy has also included most talked about an important point for this time now in our country on the topic itself, the big facilitator for Atmanirbhar Bharat, which is important, which is being very favorite of our Prime Minister, and he has created the effort and the one like everybody want to do something for India and which is self-reliant. And it is rightly so, as the progressive nations have got and adopted the reverse engineering for their growth and for their industries and to maintain their superiority. Mr. Ghosh mentioned about Japan and China of late very aptly, and this is they did so because not just for a choice but also for the necessity. I once again thank Mr. Ghosh for choosing this topic, important topic, and the GBS Energy, and inviting me for this webinar to share my thoughts. When Mr. Ghosh invited me to the webinar and requested me to address the gathering, I thought, what do I cover? I found he invited experts from various fields who will be speaking about reverse engineering and in their own fields. And I thought of covering very briefly about reverse engineering with one example, maybe how it is used now and the importance of this one. And as because I am from steel industry, I thought I'll cover some part of this use of the steel in the reverse engineering in the steel industry itself. Now coming to what is reverse engineering in very brief, reverse engineering is a process where it enables one to use the parts, existing models and assemblies and use them to generate 3D data. The scan data and the manipulated to reproduce it as well. Mr. Shah was mentioning about it and Mr. Ghosh also covered. So reverse engineering drastically reduces the number of man hours because once you do it, earlier using calipers, measuring tapes, that they used to, so it is reduced the time very drastically to capture the accurate data in the existing geometry itself. The process of reverse engineering is used to duplicate existing components, sub-assemblies, or products when you do not have the original drawings, models, or documentation. It can be used when you need to create new components that assembly integrate with the existing ones. So by reverse engineering, one can do anything starting from producing a small golf ball to use an entire manufacturing facility and even more. To use the top quality machines and combined with the best-in-class software to make sure that everything produced meets the high standard that is expected. Having said that, in very briefly, I'll just cover one example of reverse engineering. In 2019 or so, I came across a report that is by J. Taggart of 2019. He found that Tesla, you must be knowing the electric vehicle they make. That is, it is Tesla 3 is being sent to Germany. So it was wondering why. And it is a presumption was that they purchased the German by major automaker for the sole purpose of the reverse engineering, which is a common industry practice. The buyers turned out to be no less than Porsche and Audi. Both are from Volkswagen Group, as you know. The two premium German companies, the brands are working together to develop the next generation electric vehicle platform. And they thought that they have to see the Model 3s. And as you know, Germany is very good in their engineering and so also in automobile. But once they found out the reverse engineering engineers, after doing that, they had a problem. The report stated the Porsche and Audi engineers have to change their platform of PPE, that is premium platform, because they found that Tesla Model 3 has got much more better features than they thought actually. the Model 3S platform was deemed not only technologically superior, but also cheaper as well to produce. The only solution to find ways and means to lower the cost while still achieving the technological edge over the US competitors. So it also turns that the battery cell, which is the most significant cost factor, and sure enough, the Tesla just so happens to be the current industry leader in the battery cell. So at the moment, German cannot compete with that, and it will take additional time to do so. So more than likely, Porsche and Audi will delay the PPE platform to improve their cost and make it competitive. So therefore, you may appreciate the usefulness of reverse engineering, and the countries like Japan and China, many other developed countries use the reverse engineering extensively for their benefits. There are some common reverse engineering applications. The original manufacturer no longer creates it. The original document is missing. The original manufacturer no longer exists. There is a part which is failing and needs to be redesigned to analyze competitors' products, performance for the benchmarking, to defend a patent if a competitor knocks off the product, to make modification to your manufacturing when an original CAD drawing is missing, when the original supplier cannot provide you replacement, and to update obsolete materials, antiquated manufacturing process, and to reproduce handcrafted parts and assemblies. There are many steps in reverse engineering that I'm sure many of you will cover. Just to very briefly, I can say that you start with the deciding what equipment is the best fit for your capture the data. Then you can scan it, the original geometries, then outputted will be the delivered as a point of model or mesh. This data can further be refined with the final part and combination of human manipulation and automated technology. And finally, the CAD model is to complete the manufacturing and 3D printing once again. So having said this briefly, I just covered what is that steel scenario position in the world and in India. As you all know, the steel is a very basic industry, and the nation, particularly developing country like ours, cannot ignore this industry. If you see that around the world, if you see the statistics, this is the material which is growing. If you say 120 years back in 1900, it is only 28 million ton was produced. Now it is 1.9 giga ton, that is 1,900 million ton, and it is increasing. And steel is a very versatile material. It is strong, durable, precise, stable, and endlessly recyclable, cost-effective, and safe as well. And if you see the next most used metal is aluminum, and steel is being used 40 times more than this. So therefore, after somebody mentioned about the World War II, after World War II, people thought that we need steel very much to increase the infrastructure and other engineering material. So steel is the most important. And if you see the propensity of steel use in country, there is a lot of room to develop, because world average is around 229, whereas India is just 74. So there is propensity of use is more. The countries like China, it is above 600, and Korea is above 1000. And therefore, the propensity of steel use is very high in India. We now produce around 110 million ton. And as per NSP 2017, we are going to produce around 300 million ton by FY31. Steel industry is also known as the industry of industries, because everything is there in the steel plant, you name it, starting from raw material handling, storage, blending, sintering, pelletizing, coke ovens, blast furnace, steel melting shop, that too again, basic oxygen furnace, electric arc furnace, induction furnace, casting, rolling, you name it. It is heavy, medium, small, hardware, everything is there, hardware, software, including the artificial intelligence. Now, it is said that the way fire, electricity, and internet revolutionized the world and mankind, in the similar way, artificial intelligence and quantum computing will revolutionize, because quantum computing is nothing but focused developing computer technology based on the principles of quantum theory. So we know the development is taking place in a travel, in hyperloop, and change the way their life there should be, and it is definitely welcomed and best possible way to take the advantage of it and contributing. Here I may point out that steel is a capital incentive and very high asset life. So therefore, many equipments, machinery used by steel industry are being imported here. In India, we have a lot of technocrats who have very solid experience in the steel equipment and manufacturing industries. They are the great asset who will help us and guide us in the reverse engineering, and they are eagerly waiting to help. That is just mentioned by Mr. Ghosh, and India must take benefit of the reverse engineering to progress and become an Atmanirbhar Bharat. And here I may say that as because I am in some platform, the use of reverse engineering to augment the use of steel also I propose for the different groups, and I am sure that will be taken in. With this, I once again thank GBS Energy for inviting me in this webinar and wish the webinar and the future endeavors of GBS Energy a grand success. Thank you very much.
Thank you, Mr. Sen, for your very interesting lecture. I now invite Mr. S. Mahapatro to start his speech on reverse engineering. Mr. Mahapatro, please unmute yourself. First, you have to unmute yourself. We can't hear you. Yes, you can talk now.
Am I audible?
Yes, now you are audible.
Okay. Good afternoon to everybody. Myself is S. Mahapatro. I want to give a very brief speech in regard to the various aspects of reverse engineering. Since I personally, I don't have any hands-on experience of this reverse engineering process or practice or technique. So I didn't have any opportunity like that, but also that's why actually I have preferred to give or mention, narrate some good points or what are very pertinent points in regard to reverse engineering. Speaking about the concept, as everybody of us know it also, the reverse engineering, also termed as back engineering, means going back to initial conception from the stage of materialization. In reverse engineering process, actually what we do, an existing finished product is disassembled to reveal its design and architecture and to extract knowledge from the object as to how it works and how it is made and all that, similar to the process of a research work, analysis work we do in a scientific research. Okay, I am trying it.
Okay.
Sure.
Yeah. Mr. Mahapatra, we are able to view your slide.
Yeah. So that is in regard to concept which I have already discussed. As regards to relevance and effectiveness, the question remains whether reverse engineering has at all any relevance in the present scenario when we are living in an era of rapid changes in values, ideas, and perceptions. The answer is yes. Reverse engineering is that motive force which excites research power and triggers their sense of creativity, leading to reinvention of the product to satisfy the growing need. In earlier decades after independence, a large number of engineering plants were set up in our country, most of which were equipped with foreign machineries. These plants had to face serious problems to survive because of dearth of spares due to obsolescence and also due to non-availability of necessary design and right. At that juncture, reverse engineering played the key role to inspire the engineers by utilizing their innovative and productive minds to save the situation. Obviously, that was a very bold step towards achieving self-reliance. As a matter of fact, engineering is a very versatile and dynamic industry where engineers develop products using their huge potential for innovation to produce necessities across every industry. That ultimately benefits the engineering communities as a whole, resulting in rapid economy and also achieving transactions of the financial transactions are also enhanced in a larger scale. Among plenty of advantages and merits of reverse engineering, a few are exploring the existing design and manufacturing. By adopting reverse engineering process, products can be thoroughly examined to explore deficiencies and adequacies in the individual parts, but incorporating the past inventions in the new ones. Reconstructing a product that is outdated. Reverse engineering provides the visual workout outdated things in an older product for redesigning suited. Discovering any product vulnerabilities. Reverse engineering supports finding faults in the product for taking appropriate measures to ensure the quality and also the safety aspects. Bringing less expensive and more efficient products to the market. Reverse engineering leads engineers on a path towards innovation and success in lowering the manufacturing costs and raising product effectiveness, which ultimately benefits the end users and also create opportunities to compete within and outside the country. Creating a reliable CAD model for future references. As you know that most reverse engineering processes include preparation of full working CAD files for future references. This enhances engineering productivity to a great extent. Inspiring creative minds with old ideas. Reverse engineering gives way for innovative design. During the process, an engineer might discover a system that would be useful for a completely different project. Some of the major applications and utilizations of reverse engineering. Interfacing. Reverse engineering can be used when a system is required to interface to another system to meet operational requirements. Military or commercial espionage, this is very important. Learning about an enemy's or competitor's latest research by capturing a prototype and dismantling it may result in developing a similar product or a better countermeasure against it. And another is also very important, and that we have already faced in our time also, that is obsolescence. Software items like IC chips, integral proprietary systems, become obsolete in a few years and need to be reverse engineered and redesigned also for further use. Obsolescence originated problems for hardware items, namely machine parts. Those can also be dealt with in the same manner. Competitive technical intelligence. Reverse engineering enables to understand what one's competitor is actually doing rather than what it is saying that it is doing. Now, lastly, the legalities of reverse engineering. Studying an existing technology by using reverse engineering process to figure out how it works is a constructive approach to generate new ideas for developing better solutions to particular problems. This is obviously a very powerful exercise. Technological, as all of us we know, that technological innovation doesn't take place in a vacuum. Innovators routinely draw upon the insights of others as they develop new ideas. Anybody can buy a product of the shelf and freely study it to use his creative mind to invent or discover something new. Law doesn't permit to discourage that. And last but not the least, while intellectual property right empowers an inventor, the legal ability to prevent others from using or selling an invention, lawful reverse engineering of any technology cannot be restricted by a patent holder as long as the original invention is not being explicitly copied. So those few words, I thank the organizers and also the participants. Thank you very much.
Thank you. Thank you, Mr. Mohapatra, for your interesting lecture. Our next speaker is Mr. Pranab Mukherjee, who was the director of Engineers India Limited, and he is expert in oil, gas, and petrochemical sector. Over to Mr. Mukherjee.
Mr. Pranab, we are able to view your screen. Kindly proceed.
Yeah.
I have just sent you a request to unmute yourself. Kindly unmute and then speak.
Unmute yourself first.
Very good afternoon to everybody. Every industry has its unique features, and oil and gas is an industry where practices are always the latest state of the art. This is true about the Indian oil and gas industry as well. Hence, reverse engineering can be applied in very specific areas of this industry. It is not the same as the steel or the mining or the metal industry. By the term oil and gas industry, I mean refineries, petrochemical plants, and gas processing plants. Amit, how do I change the screen?
Page down.
We'll look at reverse engineering from the point of building oil and gas plants, not from an operator's point of view. To understand how the oil and gas industry operates, first and foremost, one must understand how the projects are executed. Key to successful reverse engineering in the fields where it needs to be done lies in understanding the project execution methodologies. Oil and gas projects are executed in one of the three methods: conventional approach, lump sum turnkey approach, and hybrid approach. Conventional approach and lump sum turnkey execution are known to all. Of course, lump sum turnkey is synonymous to EPCC, engineering, procurement, construction, and commissioning, as used in other industries. Conventional approach was the most common method of executing projects till the early 90s. With plants becoming more technically intensive and contractors acquiring higher technological capabilities worldwide, LSTK system of project execution became popular. And in the oil industry, implementation of Euro 3 and Euro 4 standards was a prime mover for adoption of LSTK execution in the 1990s. There was a requirement to establish about 15 diesel hydrotreater plants simultaneously to meet emission norms. There was a severe shortfall in indigenous capabilities to build these plants, and that is when a number of big foreign contractors came in. I'll briefly describe the conventional approach. As you can see here, the client engages a consultant. Direct procurement of equipment and direct ordering of construction on contractors is done by the EPCM consultant, and the project management and client is done by the client and the consultant. LSTK approach, the word LSTK is an American word, also known as EPCC. The client appoints a PMC. The total project is split into packages. The PMC does feed and prepares LSTK packages, and the LSTK contractor executes all the balance activities. I described the two approaches for the main reason that depending on what method you adopt, possibility of technology absorption varies very widely. And that is why I am describing these two methods. There are merits and demerits of both approaches. In the conventional method of execution, the biggest advantage is that at the end of the day, the client gets his money's worth. There is substantial scope of indigenization. There is high plant flexibility, operability, and safety. There is flexibility of mid-course modifications, of execution strategies, of technical features. And all these enable the client to absorb technology, to modify plant components as required. And in the LSTK, the whole thing becomes opaque. Clients, there are, however, good reasons for clients to tend towards LSTK execution, because there are limited number of responsibility points for the client. It is only award of packages and then leaving it to the LSTK contractor. There is minimal micro-level interface. The main advantage is that there is a single guarantee which is available for covering time of completion, project cost, and performance. The owner also needs to keep a minimal workforce. The key takeaways from what I have just discussed is that as plants become more technically complex, LSTK contractors with specialized experience start dominating, which is already happening in the oil and gas field. Clients are not always technologically nimble, and hence they find it convenient to use LSTK route. Contractors strictly go by the contract, and they tend to provide bare minimum facilities in an LSTK contract. So there is no flexibility, no scope for expansion for plants constructed in the LSTK mode. This is where the main disadvantage comes. And this is where the requirement of reverse engineering is felt by almost all clients. In LSTK execution, all activities are done by contractor, so that there is no scope for learning, let alone innovation or improvisation. There's no scope for development of indigenous capabilities because most of the LSTK contractors are foreign. And it is now become necessary to reverse this trend and to move in a conventional execution mode if we have to develop indigenous capabilities, if we have to do reverse engineering in areas where the requirement of reverse engineering is being felt. And that is something which all clients are starting to feel. So there is a tendency to go back to conventional execution in many of the refineries and petrochemical plants, which are now planning to have expansions. The way forward is, as I have shown, we need to understand the detailed engineering capabilities of the oil and gas industry plants already exist within the country. Process know-how of all thermal processes are there. It is the catalytic processes, the secondary and tertiary treatments to achieve latest emission norms that are developed and patented by specialist foreign companies. This is where we lack know-how. In India, we have strictly adhered to intellectual property rules. Each time we have used a license process We have got the feed done by a licensor and paid licensing fees. Our neighboring country, who has been named many times, has paid license fee only once in each type of plant and then carried out reverse engineering. They have scaled up, scaled down plants. They have copied equipment drawings, and they have analyzed catalysts, chemically analyzed catalysts, and produced catalysts illegally on their own. This is the way forward for India also. However, we have to see how flouting intellectual property rules can be avoided. This is an important point. India does not want to flout intellectual property rules. We have to go back to our existing plants and also build pilot plants to develop the chemical engineering know-how for process engineering. From pilot projects will emerge basic engineering know-how. This is the reverse engineering that needs to be done in the oil and gas sector. Experienced engineers who have had long exposure to conventional execution of projects and who have developed familiarity hands-on can handhold the younger generation to achieve this goal. From the early 70s, when more than 90% of equipment had to be imported for the oil and gas industry, we have now reached a stage where 80 to 90% of the equipment is now produced indigenously. Mind you, these are highly specialized equipment. A massive effort has been made in vendor development over the past 2 decades in the oil and gas sector. This is one of the most successful stories of transfer of technology. This was planned reverse engineering, as I call it. First, there was technology transfer agreement with renowned manufacturers. It was followed by development locally. Vendors like L&T, Bharat Pumps and Compressors, Walchatnagar Industries, BHEL, and so many others have developed specialized equipment like pumps, compressors, turbines, and all kinds of vessels, internals, columns, everything. Capabilities have all been developed in India over the past 20, 30 years. However, some specialized equipment are still not produced in India. An example is the coke cutting pump. I thought I'll give an example. A coke cutting pump is a centrifugal barrel type pump with extremely high discharge pressures. And these are used for cutting coke in the coke drums. And these were installed recently in the delayed coker unit in Haldia refinery. India can't manufacture coke cutting pumps. There are basically 2 vendors in the world. Similarly, there are a few technically complex and specialized equipment which are not manufactured. Oil and gas industry equipment which are not manufactured in India. High pressure reactors is another area. And these were not made here earlier, but are now being fabricated by L&T in their Hazira plant. But I think that on the whole, trying to cover this last 5 to 10% of equipment and trying to manufacture it in India may not be worthwhile, because these are so few in number and the requirement is so low that manufacturers may not be interested in developing the plant facilities which are required for manufacturing such specialized equipment. We would also need to do reverse engineering in the catalysts. Catalytic processes require catalysts which have to be refilled every 3 months, 6 months, or 1 year. We need to carry out chemical analysis and possibly tweak the molecular structure of catalysts to avoid patent infringement. To sum up, in the oil industry, reverse engineering should primarily be aimed at the soft part, that is acquiring and commercializing process engineering capabilities and in catalyst production. In the area of hardware, of equipment manufacturing, we are already there by and large. Thank you.
Thank you. Thank you, Mr. Mukherjee. I now invite Mr. Arunabh Dattagupta to start his presentation. Mr. Dattagupta.
Good afternoon. I am Arunabh Dattagupta. I'm basically a salesman, and I'm not an expert in reverse engineering, but for years, studied a lot of
Mr. Dattagupta, your audio is not okay. We have problem in listening. Please bring the microphone nearer to you.
Hello.
Hello.
Can you hear now?
Now it's better.
Can you hear now,
carry.
please?
Yeah, it's better now. You can carry on.
Thank you. I would like to, as I was telling, that I have a firm conviction that reverse engineering would be a big facilitator for the country to take to the next level, particularly for implementation of Atmanirbhar Bharat. So I will start with my presentation with a very interesting note. You all must be knowing about the Dell computer and Dell laptop. Now, if you see, Dell, born in February 65, is the founder, chairman, and CEO of Dell Technologies. He purchased a calculator at the age of 7. He soon disassembled and reassembled the whole calculator. At age of 15, he had his first computer, Apple version 2. He soon disassembled it to see how it works. He also started supplying add-on components and PC upgrades to his own peers in the college hostels, in the school hostels, and to the seniors. Even some of the teachers and professors used to come and take his help at that age. In 1984, he started producing and selling computers directly to customers, bypassing the retail channel. Thus, he could substantially reduce the cost of his products. What did Dell do? At the tender age of 15, he decided to take help of reverse engineering without knowing what RE is. He was convinced of few things. Fastest way to understand the mechanism and technology is to dissect best product available in market. Identify areas of improvement and develop a product which is much better than the original one. It saved time, money, and energy. Dell is ranked 25th richest in the world by Bloomberg Billionaires Index with a net worth of US dollar 51.7 billion as of April 17, 2021. This is the story of Atmanirbhar Dell. To become Atmanirbhar Bharat, reverse engineering should be the best facilitating resources. RE should be compulsory subject in engineering, bioscience and technology, pharmacy courses, including the legal aspects involved on this subject. Governments in center and state, large industries and business houses, R&D labs to focus on implementation of the RE-based ventures. That's my point. Thank you.
Thank you. Thank you. Thank you, Mr. Dattagupta, for your short but crisp presentation. I now invite Mr. S.K. Gupta. Mr. Gupta is the MD of Crane Manufacturing India Private Limited and Crane Solar. Over to you, Mr. Gupta. Please start your presentation.
Thank you. Good evening, everybody. First of all, I appreciate for the effort taken by my friend Amitabh Ghosh. Can you hear me, please? Amitabh Ghosh, who has organized this wonderful seminar, and you know, it makes me a lot of admiration to say that this is a wonderful subject. As one of my very old friend, we have 53-year-old friendship, and when we share some subject, it is a subject. Let me tell you something about my company. We were working in engineering, and I left company in 1990 and started with small order of 15,000 rupees. Afterward, we never looked back. Today, we have two industry having more than 60,000 square feet area, making EOT cranes and 5 to 6 cranes in a month worth 2 crore. And as you know, steel is the base of 19, where all the prices have gone up between 15 to 20%, but steel had gone for 40%. And when we were talking about costing of cranes, then we found that it is difficult to survive. During October to March 1921, we lost almost 70 lakhs towards only cost of steel because of the increase in cost. It was very difficult to survive, but what happened in between, Mr. Ghosh came into this concept of reverse engineering. Hello? Concept of reverse engineering. Can you hear me, please?
Yeah, we can hear you, but it should be more better. You can bring your microphone a bit closer.
Okay, okay. So what happened that with this COVID and all over world and India, of course, and the conditions of industry were so bad, especially in Mumbai, which was center of this high COVID in Mumbai. And we have to survive. And how to survive, we started working on value engineering, how to reduce the cost, how to increase the productivity. Then we start going for automation, have the machines for fast cutting machines, welding machines automated. We reduce the overheads. Then we did something new, which I want to share with you. One day, fine morning, Mr. Amitabh Ghosh landed in Mumbai. That was 2015. And we were discussing about, he just reminded me my about the solar energy. And we were discussing in the office, and all of a sudden he remembered is one of the old friend who was MTech from IIT Mumbai, expert in solar. And within few hours, we could catch hold of him, this gentleman. Next 3 days, we finalized the deal with him. We installed solar rooftop solar system in both of my factories. And so this was worth 60 kilowatt initially. And we were producing, consuming power for ourselves worth more than 1.2 lakhs. And we have completed, we have paid back the total money on the spend on the solar. And today I'm enjoying at least minimum 1 lakh per month. And this will be for 20 years next. That is almost 2.5 crore worth of solar. So I just wanted to say that about my friend, Amitabh Ghosh. Another thing happened, he one day, fine morning, he become Bajrang Bali for me, Hanuman. And he said, what are you doing? I said, I am worried about the costing of the crane. I am very difficult to survive. We have orders of 60 cranes for 40 crores. And how do we survive? Then he said, I will give you some jadoo ki chhadi. And he said, right, okay, there is a subject value engineering. How do you do it? Then we shared our thought. See, both of us are design, and I am more than 54 years we are together in the engineering industry. So we start working on the subject and sharing day to day. And what happened that basically the concept of engineering, that crane design has come from Russia during Vilai steel plant and Bokaro steel plant. And they are, as you know, Russia is very heavy design, having very heavy design. So we start working on this. Initially, WMI was the pioneer on the crane and garlic engineering. Now garlic engineering close. I don't compare myself, my company with garlic, but yes, we are one of the major supplier to railway and industries, ordnance factories and other government companies. What happened then coming back to battery engineering, and we discussed about that how do we go about it, and I started working on actual load instead of calculated load. Normally what is happening in crane industry, we assume that this is the wheel load on particular crane or wheel load on the gantry rate. And we were not going very much in detail. Now what we did, we start working out on actual loads. And then we found there is a tremendous increase or decrease in actual wheel load. And then we found simultaneously also we see that how do you convert that actual wheel load to the girder sections. And then we found that there is a fantastic reduction. I will just give you an example in last 1 month, because this was introduced to me only 1.5 months back. Last 1 month, we are consuming about 75 ton steel per month. I could save almost 6 ton steel on the 6 number cranes. That is almost 8% reduction in this, which is in today's scenario is a very big thing. Now we are in process converting these calculation into electronic thing and software. If we are able to achieve this with the help of my all friends, if anybody among those people who can help us, we can be one of the pioneer in this crane industry by reducing the and using the value engineering. Friends, this was a small my experience. I can only say that this is our first step towards reverse engineering. Beginning of the beginning, we say that it is always start with beginning, and if we have really action, okay, yes, we can do it. Yeah, I think it is possible to do all these things. Thank you very much. God bless you.
Thank you, Mr. Gupta, for your very interesting lecture and case study based talks. It will help many people, I am sure. Our next speaker is Mr. Somnath Bhattacharya. Mr. Somnath Bhattacharya is a steel designer, and he will throw more lights on the talk of Mr. Gupta, I think. Please, Mr. Bhattacharya, please start.
Okay, I'd just like to take a minute for the panelists. There is a question lying there in Q&A section. If you have some time, kindly answer. And for the attendees, if you are having any question, please refer your name as well. It doesn't look like who is questioning if it is not mentioned the name. Thank you.
So it is to Mr. S.K. Gupta. I'm addressing to Mr. Gupta, S.K. Gupta. My name is S.K. Rana.
Already finished my.
hear me? Can you hear me?
Yeah, I can
Mr.
hear.
Rana, it's
Yes,
not your.
yes.
Mr. Rana, please talk later. It's Mr.
Okay, okay,
Bhattacharya
fine.
is presenting.
Okay, fine, fine.
Okay. Can you start?
Yeah, please go ahead.
Mr. Bhattacharya, please start.
Good afternoon. I'll start with some basics of reverse engineering. It is an act, it is rather reverse engineering is a very useful tool of classical engineering. It is an act of dismantling an object and understanding how it functions, analyze, gain knowledge to replicate to preferably with added values and features. Reverse engineering can be done for process, technology, equipments, parts, genetic research, and many more. The basic steps are collection of information, extraction of information, modeling, and then review. Then, so that the model or any experiment is tested for actual duty conditions. Then we can go for the final solution. Now I'll go uh, where reverse engineering applied of my experience. I am from the LSTK execution group. Wherever I worked, they were the LSTK contractor. So from LSTK group, I looked after the engineering. The first project, which I'm giving you example, ONGC in 1998 has gone for a very skid-mounted mini refinery, 335 barrels per day. It is the first time in India, and my company has won that order, LSTK order, and we started the execution. It's a very mini refinery. It is in comparison to refineries in Haldia or Panipat, or just all very everything is skid mounted. So we collaborated with a technology provider based in US. They were the world leader, and they made the similar plants in Russia, Romania, etc. They provided the basic engineering package and helped to develop the layout as per the prevailing safety protocol as OISD. All hydrocarbon plant has to follow oil industry's safety directive in our country. For detailed design, we found this is a very costly proposition from our collaborator. Then we decided, though it's very new to us, we decided the detail engineering will do internally. This has got three main parts: fire heater, pumps and heat exchangers, and the distillation column. Fire heater is entirely indigenous design. There is no issue about it. Pumps and heat exchangers has to be mounted on skids. Skid dimension was prefixed because it has to be shifted from one place to another. So that skid dimension was around, so far as I remember, 2.8 meter by 5.5 by 3 meter with lifting lugs. And the two levels are there. We have to design our equipments, select our pumps and heat exchangers based on that dimension. And few heat exchangers we have to design as hairpin also. So this and distillation column was designed as 5.5 meter segment with intermediate gut flanges. Based on these reference documents of the collaborator and using here this reverse engineering technique, the equipments for entire detail engineering done were developed by us indigenously, and successfully plant was commissioned. And when EC have given us a repeat order to have another plant adjacent to this plant. The location is at Tatipaka, 70 kilometers from Rajamundry, is in the rice bowl of Andhra Pradesh. The second one, it's a project, it's a lifetime project for me. It is the raw material handling package of Durgapur steel plant. The magnitude of this thing, you can understand. There are 212 conveyors having 23 kilometers of belting, 18 stockyard machines, mechanical equipment 55,000 ton, civil work 1,45,000 meter cube, structural steel was 60,000 metric ton. Scope was, with our consortium partner Cook Germany, was stockyard machine engineering, complete engineering, and supply of key components. Balance entire engineering, erection, commissioning, A to Z work was allotted to Binder Technical Service, where I was working. I was one of the team members. Key to BTS success. For BTS, it was a very, very successful project. And key to BTS success was solving issues on spot by reverse field engineering. BTS worked in a different model. The entire design team was shifted to the site when it was executed, and there is such a vast project. Lot of things, lot of issues are raised, lot of changes has to be made. So everything has been sorted out by reverse engineering. I'm not going into all details, but especially I want to mention about the stockyard machines. Stockyard machines include the stacker reclaimer with a unique design of crook, blender reclaimers, wing tippers, transfer cars. All engineering drawing was given by Crook. After that, we manufactured, assembled, erected everything from BTS up. So do so. There are lot of issues that come, which is very practical. Everything cannot be just like that. It will match and this thing. So we, the BTS team, technical team, sat down with all these drawings and documents of Crook, and gaps we have studied. We studied, started with your what is required, then went back and sorted out all issues one by one. It may be in manufacturing stage, it may be assembly stage, it may be erection stage, it may be in commissioning stage also. In this process, the BTS team has become an expert in this stockyard machine. Now I discuss about which are the areas we can go for reverse engineering. It will be very fruitful. Reverse engineering can be done. Why I worked. First one I have already mentioned. The team of BTS are confident and can do entire engineering of stockyard machines and extend help in manufacturing process. Second one is floating roof in big oil tanks. I worked in oil and gas crude oil and large tanks. Up to, my experience of biggest tank is 80-meter diameter for crane energy. There are double deck roof is there. You see, after Jaipur fire, Mr. M.B. Lal's recommendation has become mandatory, and he recommended that for all floating roof, the foam tank and pump, everything has to be mounted on the floating roof. Earlier it was at the ground, it was pumped from the bottom with a pipe. But he recommended that everything has to be on the floating roof. So increased dead weight, submergence is increased. The entire design have to be revisited after that recommendation. So here, a lot of reverse engineering can be done, and Indian Oil had placed an assignment to us, my last company, Mott MacDonald, to do an alternative design, and we made a report of providing aluminium, made out of aluminium deck report. That report has been submitted to Indian Oil. So I think in this area, a lot of improvement can be done through reverse engineering. Another area, I had worked in the few steel plants, blast furnace and coke ovens. We are operating Indian for last 50 years, more than 50 years we are operating steel plant. But if any blast furnace or coke oven rebuilding project comes, for technology we have to go to China or Gipromax or Polwart and a lot of things. I think in this area, all technocrats should sit together and develop our own technology. We have got all data, and reverse engineering is ideal for applicable in this area. Fourth is oil separation technology in gas collecting stations. Lastly, most important thing is topside engineering of offshore. In this area, Indian companies doesn't do anything. In this, I can say my last company, I tried to develop one, and I got the training in IIT Chennai on this, and this can be developed. I tried to develop. I discussed with ONGC offshore executive director. He wanted to help me also, but things are not. It is all these things are taken out by the foreign companies, and our Indian engineers are doing their working there. So these also can be developed through reverse engineering, and a lot of things can be done in this area. With this, I am concluding. It is high time to go for brainstorming on reverse engineering, facilitate Atmanirbhar Bharat, particularly in this COVID situation. Thank you.
Thank you, Mr. Bhattacharya. Uh, our next speaker is Mr. Devobroto De. And Mr. Devobroto De was ex-director WBPTCL. I now invite Mr. De to start his lecture. Mr. De, please take over.
Hello, good evening, everybody. At the outset, let me convey my gratitude to GBS, the organizer, for giving me an opportunity to speak few words regarding reverse engineering, which I am little aware of. Thanks to host Amit, moderator Mr. Arnav, and my respect to all other senior panelists. Special thanks to 135 viewers who took a lot of pain to get registered, and they are now online viewing our speech. By the way, I understand by this time we are at the midway of the webinar. The elite panelist with wealth of knowledge and experience spoke volumes regarding reverse engineering, covering almost all the areas. After that, I have little to say. Still, let me go through my slides very quickly, and I will I will tell you a story, my hands-on story regarding reverse engineering in early 80s. First, why reverse engineering? Why reverse engineering? Actually, in my knowledge or in my opinion, when an old foreign product, component or machine fails to deliver useful service, but the machine as a whole still working, then comes the idea of reverse engineering. In early 80s, we did not know what is reverse engineering. We normally we normally tell it import substitute. Most of the products in power plant are imported. And let me tell about I'll tell you the story regarding Bandel. That product still in operation is reduced efficiency, high input cost in US dollar from the OEM, approval of Forex from government of India is very difficult, no drawing data sheet available, no Indian manufacturer available, and import substitute is a must. What is reverse engineering? I think already my actually senior speakers already told you. I did not want to repeat. Some benefits, benefits also retrieving imported design, etc., already actually shared by my senior panelists. Next again, some more benefits already shared. Now let me come to the example of BTPS, my hands-on experience. Again, I tell you, my hands-on experience with BTPS. At that time, maybe in the year 1980 or 1981, I was simply an assistant maintenance engineer. I repeat, an assistant maintenance engineer in turbine and auxiliaries department. Actually, you know, perhaps the bundle old units, that is 4 into 82.5 megawatt units, are pretty old. These were commissioned in mid 60s, and very in the time of Vidhan Chandra Ray, and it was the whole equipment and component, everything was supplied on a turnkey basis by Kuljan Corporation and Westinghouse. Actually, there are 4 units, and each unit are having 3 boiler feed pumps. Those 3 boiler feed pumps were supplied by an USA company, Pacific Pumps. Perhaps you have heard of it. Pacific Pumps, a big company, a pump supplier. What we felt when Kuljan Corporation and Westinghouse handed over the entire plant to West Bengal State Electricity Board, they have just given a few spares for all the machineries, out of which definitely boiler feed pump was there. But the number of spares was not adequate. And after a span of 10-15 years, these spares got exhausted. And when we have tried to import the spares from Pacific Pumps, it was very costly and it was taking a lot of time. Delivery schedule was hard, very long, and moreover, we have faced a lot of problem for the release of foreign exchange, that is US dollar, from the government of India. A lot of NOC to be taken from Reserve Bank, from GOI, blah blah, and then one of our engineer, my senior engineer, Mr. Ravin Mandal, he took the challenge and he thought, why can't we develop? And particularly in the boiler feed pump, we found that the suction impeller, suction impeller is getting eroded and corroded after a continuous run of 1 year or so. And others, okay, others actually the discharge impellers, maybe 7 or 8 discharge impellers, there is no problem. The problem was with the suction impeller. Actually, the water coming from the deaerator may not be having the such type of purity. That's why suction impeller is getting corroded as well as eroded. And when the suction impeller is getting corroded and eroded, and if it is allowed to run, the pump efficiency is very low. And what happened at that time, we had failed to maintain the rated load 80 megawatt or 82.5 megawatt by running 2 pumps in parallel. Actually, out of 3 pumps, 2 pumps are good enough to actually deliver the full load. But when the suction impellers is found eroded or corroded, we have to run 3 pumps. We have to run 3 pumps to get 80 megawatt load. That was the problem. And actually, the problem is suction impeller. Then Mr. Mandal, he has taken the challenge. He has taken all the measurements. He has actually deconstructed the pump, taken out the suction impeller, and taken all the all the actually parameters, the design, drawing parameters, and also from the particular actually suction impeller. just using simple instrument like slide rule, vernier caliper, outside micrometer, vernier height gauge, scale, blah 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 blah. Nothing actually. At that time, I just think I am talking about 1981, 80, 81, and the most difficult part of the drawing was the vein angle. Vein angle of the suction impeller. How could he manage to draw the development? How could he manage? I saw what he did. He used some, actually, uh, he, he, he's, he used to cut a slit on the suction impeller so that vein could be found out and the vein angle could be measured with the instrument he is having, a local instrument or Indian instrument. Accordingly, he measured the vein angle, he developed the drawing in the drawing board, then everything was ready. He also actually sent the material, sample of the material to a lab to get the composition of the suction impeller. After getting all these things, material composition as well as drawing, design data, okay, design data was available in the maintenance manual, no problem. Then he called one Indian company, but better I would say a company from Howrah. You know Howrah? Howrah, at that time, Howrah was the Glasgow. Howrah was the Glasgow of India. He called a, actually, that gentleman was not an engineer, Jivon Krishna Das. His name was Jivon Krishna Das of Modern Engineering Howrah. He called that gentleman. He supplied all the papers, that is material composition, drawing, design data, everything. And he said in front of me to that gentleman, well, Mr. Das, if you can manufacture this impeller within the shortest possible time, and after assembly of this suction impeller in a pump, if we find the performance is satisfactory, then we are going to give a order for 15 number suction impeller. But you have to carry out this work free of cost. I repeat, you have to carry out this work free of cost. Then that gentleman or the actually owner of Modern Engineering, they agreed, okay, considering the commercial aspects of the future business. Well, they have taken 3 months time, and after 3 months, they supplied. After 3 months, they supplied the suction impeller. It was, but we cannot. It was not possible at that time to assemble the suction impeller immediately, until and unless one shutdown or the capital overhaul of the unit is available. Maybe within 3 months, the unit number 1 of Pendle's power station was actually shut down for capital overhaul. One special team, I repeat, one special team of technicians were engaged. Mr. Mandal was there, I was also there, and they have opened the pump. The suction impeller was assembled, the pump was assembled, trial run was given, and it was commissioned. Okay, fine. The pump, at that time, the pump had run successfully. All the parameters or better parameters were available. And most important thing is the power consumption was less. I repeat, most important thing was the power consumption was less compared to Pacific suction impeller. But one disadvantage was also there. Disadvantage was also there when actually suction impeller of our indigenous product and a suction impeller of Pacific pump was run in parallel. Then actually the load sharing was unable. Okay, thank you. Perhaps I have spent my time. Thank you very much for listening to my.
Thank you, Mr. Dev, for your lecture. We now invite.
No, it's a hands-on experience. It's a hands-on experience. You
Okay.
both appreciate it's a hands-on experience. And also 40 years back, not today, 40 years back.
Okay,
And I was
Dey,
part.
thank you.
I was assistant maintenance engineer. That was
I
start of my journey.
Our next speaker, Mr. Hello, our next speaker is Mr. Lalit Tejwani. Mr. Tejwani is the Chief Marketing Officer of Hind Rectifiers Limited, and he will share his thoughts with the audience and panelists. Thank you. Mr. Tejwani, please start.
Good afternoon, everyone. First of all, I would like to thank GBS Energy for organizing such an interesting and relevant seminar. I hope my screen is visible.
Yeah.
Yes, it is visible.
So I'm working as the Chief Marketing Officer for Hind Rectifiers Limited. And all my esteemed panelists have spoken from the aspect of various industries. I would like to address the topic of reverse engineering in perspective of control systems and automation systems in the industry. So the first part we have to look at the drivers of why we need to have reverse engineering. So we look at it in three parts. One is for legacy systems, automation systems, which are already installed in long service life installations like we saw earlier in steel plants, oil and gas, power plants, and also in equipment like trains and ships where Hind Rectifiers is dealing more in railways. So even train, the lifetime is 30 to 35 years. So the automation systems have to be up to date and running the train for 30, 35 years, which is a challenge for any electronics. As we know, it keeps upgrading very fast. So because of the obsolescence of electronic components, the change of software, also the change in the environment with the interfacing with different automation systems, there are increased downtimes and decreased serviceability of these legacy systems. This is the key driver for investing in reverse engineering and modifying the existing automation with new hardware and software. Then another aspect is if I already have a product which I know that this is required for an application, but it is not available in India due to a lot of restrictions which have come up lately for Make in India, for land border issues, for minimum localization content. I want to develop a new product, but to start from scratch means a lot of iterations and a lot of, let's say, R&D effort. If I have a product which is a benchmark, then I can quickly start up the development with minimum number of iterations, reach the state of the art. The third aspect to look at is I have a product which is working, but I know there are better things in the market. So I'll look at improving my product with higher functionality, reduced raw material costs, or even reduced manufacturing costs. So for that, I take a competitor's product and I reverse engineer the functionality into my existing product. So this is the three ways we look at reverse engineering. I'll focus more on the legacy systems, basically. So when we look at automation systems in the industry, we see a lot of digitization going on in the last 10, 15 years. And all the associated control systems are being upgraded continuously. So maybe 5, 6 decades back, we were talking of process control with distributed automation systems. And now we are talking of higher productivity, energy saving, making the quality better, and even doing predictive maintenance in the factories so that we have minimum downtimes. So basically, industry is moving very quickly into digitization, industry 4.0, smart manufacturing. And that is a challenge for the legacy system, which were not designed for today's working environment. India has to adapt this new technology so that our products are also as competitive, as quality conscious, and as, let's say, productive the workforce as we have the global players in the market today. Looking at legacy systems, again, because of the old systems, these companies may have been acquired by larger organizations, or they may have changed their functions and products in the meantime. The expertise becomes difficult to come by. Also, the obsolescence in the electronics and controllers cause the equipment to become more expensive. If you look at software, just the maintenance cost is more than 50% of the software cost. So all these factors, they lead to a challenge for a company who's using a legacy automation system in today's environment. So again, when we start, how do we start? So we have three aspects to consider. One is the application and the environment in which we are wanting a new automation system. We have to define how it will behave in terms of protocols and interfaces with the environment. And third is which technology, which production capacity we should apply to make this new automation system. So looking at each one in a bit more detail, we have application environmental issues. We have to map the process, like we discussed, our senior panelists also mentioned. We have to look at the functionalities and the limitations, the envelope in which the new automation system has to operate, which legalities it has to adhere to. And then we look at the deliverables and the algorithms, the logic basically of the process. Another aspect is the protocols and the interfaces. So in which way the automation system is speaking to the environment. So when I'm making a new automation system, I have to map the input outputs. What are the communication protocols to be followed? All the hardware and software requirements from the external point of view. And also what type of processing power, the speed of scanning the input outputs, and then finally documenting all the above. Then we come to where we are. We are in India. We are a company which is already having an expertise in a certain area, in a certain type of hardware and software. So we have to choose which type of, let's say, hardware and software we apply for this type of application. So in today's world, many of the microcontrollers are being replaced by field programmable arrays, and they are all embedded system graphics which can be, let's say, modified very quickly on the field. So once we decide which type of environment we want to create and look at the production capability of that company, the expertise available in that company, and then we look at the economy of scale, whether this adjacency will help the company to become more automated and more economical. So I would like to give the audience a small example of how Hind Rectifiers has achieved this type of reverse engineering for certain control systems. Just a snapshot of our company first. We are a 60-plus-year-old company, started in 1958 with Westinghouse Brake and Signal. We are public listed with 800 employees and about 120 in R&D. So from our verticals, basically the industry side, I think because we have a lot of audience from the steel and power sector, must be aware for high voltage power supplies for ESP application. Hind Rectifier is one of the leaders. And also for high current rectifiers for electrolysis and hydrogenation and such type of applications, we are one of the leaders. So in railways, we are doing a lot of electronic systems, converters, inverters, transformers, motors, panels. So my example is mainly from the railway side. In early 2000, 2005, we have been doing a technology transfer with the European companies on making converters and inverters for locomotives as well as passenger coaches. So in the meantime, in the last 2 decades, our company has manufactured and supplied thousands of such units, and they are working fine. We are doing the annual maintenance contract. But then the question comes from railways every couple of years, they need new hardware and protection features to be built into the system. And although our technology transfer gave us the know-how of manufacturing, but they don't tell us the know-why of manufacturing. So they keep some information with them, which is proprietary. So we are not allowed to change the control cards, the software, the functionality embedded in the firmware. So this was achieved in the last 3-4 years. Our R&D team has been working very hard, because when we have to buy new cards, the electronic components are obsolete. Because of all these COVID situation, the cards have to be imported from outside. They come very late, and any breakdown in the coach or the locomotive adds a penalty to us as the annual maintenance contract is going on. So because of all these challenges, our R&D team has developed these control cards in-house by doing reverse engineering and meet the client's requirements in terms of availability and reliability. So this was a small introduction from my side. Thank you very much for your attention, and thanks to GBS Energy for this opportunity. Thank you.
Thank you, Mr. Lalit, for your interesting lecture. Our next speaker is Dr. Nitish Ranjan Mandal. Mr. Mandal was a professor of IIT Kharagpur in ocean engineering and naval architecture. Over to Dr. Mandal.
Mr. Nishit, you need to unmute yourself first.
Muted.
Thank you. You are again muted.
Please unmute yourself.
Yes, yes.
Yeah, thank
it was
you.
not getting unmuted. The mouse, the technology creates problem.
Now it's okay. It's perfect now. It's perfect.
Yeah. Thank you very much. Thank you. Good evening, everybody, once again. And I must thank GBS Energy for giving me this opportunity to share some of my views. We have already heard quite a lot from many of the industry experts. But at the outset, let me thank Mr. Atmanirbhar for me, for enthusing me that you come and say something. I said, what do I know? What I will say? But anyway, eventually cannot avoid Atmanirbhar once he puts in a request, and his sincere effort of doing these things are really commendable. Definitely it will go a long way, I'm sure. Anyway, I would like to share some of my experiences, some of my views on reverse engineering as far as shipbuilding and ship repair is concerned, because as you have seen, I am from that background. Sorry. Okay, this is of course, I mean, we have already talked about what is the reverse engineering, but here for me means for the shipbuilding sector, repairing as well as new construction, it is essentially for when I'm talking about the ship hull, it is actually surface reconstruction, the hull reconstruction, the surface. So where it is done, where the design data that is available, but the data is derived from the part itself. There we do the reverse engineering, whatever needed that is possible in shipbuilding or ship repair. So where it is used, we have already talked about. I mean, for product development, or where a handcrafted or illustrative or design model is done, that model is transferred into a CAD model for prototype construction. Anyway, these are already talked about. In shipbuilding, in particular, what happens? We need a 3D measure data, which forms the basis of for the surface reconstruction. Once that surface reconstruction is done, that we put in the CAD model. From that CAD model, we can then easily manufacture the required surface. For example, repair of a damaged ship hull surface, a ship hull, a particular area has got damaged. For some reason, I have to replace that part with a fresh piece of plate, but that plate should match the hull surface. That means that hull geometry, whatever the curvature, it should match. How do I get that? Because as you know, often it will happen that a ship is in service for, say, last 15 years, and it has met with some minor accident, some hull got punctured, or some piece of hull piece got damaged. It's coming for dry docking, you have to repair it. While it is coming for dry docking, for repairing, how do you get the surface? So there it comes the so-called necessity of so-called reverse engineering. You don't have the design drawing then at your disposal. You'll have to make necessary measurements at site, from that reconstruct that surface and do that. Similarly, for replacement of damaged turbine blades, the steam turbines or gas turbines, the turbine blades gets damaged. For repairing that, also, you may not have the design drawing. So there we can do the reverse engineering. Here in this, I can relate some small example we actually had. I mean, quite some time back, way back in, as I recall, probably sometime in 93, 94 or so. As you get to hear, very many accidents that take place in the country boats. Very often you hear about country boats capsizing, etc. So we were entrusted upon to look into this aspect. We means the Department of Ocean Engineering at IIT Kharagpur by West Bengal government, to look into that what can be done about it, how to enhance safety. So we did extensive survey of these country boats. You know, the country boats are those wooden boats which are the so-called lifeline of the Sundarban area. They call it Bhutbhuti. So many hundreds of these Bhutbhutis they fly in that area. So we went there to make a survey, and we found that there is a place called Bolagad in NH in this Delhi Road in Hooghly district, which is the manufacturing place for this these country boats, these wooden boats. We found that they are manufacturing, they don't have even a measuring scale, they use their hand. So many hand length. That is how all these things are done. So question of design, drawing, nothing is there. So then what we did, we made a number of visits to the Sundarban area where the vessels are plying. We took physical measurements of those boats, came back, put them and reconstructed the hull surface, the design. The hull surface was reconstructed. From that, we worked out, we did all the calculations as to assess what levels of safety they are following. You know, there are certain norms in shipbuilding that a floating object should have so much of metacentric height minimum, so that it has it won't capsize, or it will have a righting moment so much. So we did all that calculations and we found what is the level. And then from that, we walked ahead to suggest what are the minimum modifications to that design can be done so as to enhance the safety. And that we suggested. There also through calculations we could see and we could show that, well, this was your level of safety. Now we have increased it.
Mr. Nishit, are you there? I think Mr. Arnab, his Network connectivity.
Hello. Dr. Mandal, can you hear us?
I think his internet connectivity is down. He is disconnected. I just let's move to the other panelist. When he will be back, he can continue.
So we are going to the next speaker, Mr. Rana. Mr. Saroj Kumar Rana, request him to start his lecture, and we will resume to Dr. Mandal's lecture when he is connectable.
Okay.
So, Mr. Rana, please start your.
Okay. Good afternoon to you all.
Yeah. Sorry.
Yeah.
Oh, yes.
Mr.
Dr. Mandal is back, so let him continue his part, and then Mr. Rana will start.
Oh, okay.
Please
So,
continue.
I mean, there's a glitch in the connectivity. The screen is again. I'll have to share, right? Or it's
Yeah. You have to reshare the
okay.
screen.
Okay. Just a minute. I'll go faster and.
No worries. We can see your screen now.
Yeah. Okay. So, anyway, so if we go back to this concept of reverse engineering, how does it work as far as shipbuilding? It's essentially reconstructing the surface. Now, how to reconstruct the surface? This is one of another example of actual real life reverse engineering. This we did in one of the shipyard in Calcutta, Garden Ridge yard. Here you can see the actual block is being manufactured. So a part of the area, the hull area, is reconstructed here, right? That digital surface reconstruction, a part of the hull surface has been reconstructed. This was done for different purpose, of course, to assess how much deformation it's undergoing because of the welding, etc. But if we talk about that, what I was talking about, if there is some rupture, some damage has taken place at some part of the hull, that can be particular plate has to be replaced. So that can be reconstructed digitally by taking measurements. Here is the actual technology involved. I mean, the basis, there is a measurement. Like in that Sundarban country boards, we have talked about measurement. There was a physical measurement using scale, tape, etc. But here it is not. Here we'll have to go for such because this type of these things, just by measuring physically, it will not be effective. So what we need is 3D scanning as quickly and easily. The volume model has to be generated through 3D scanning. Now, how do you do that 3D scanning? That is the main thing. So, I mean, once again, if you go back, that scan data means that measured data can be used, can serve as a basis for alteration, not only for as I am saying, for repair, but for new construction in the newer series of the vessels. We can use it for improvement to modify the surface geometrical properties. Well, this we have already, people have talked about. It saves time, etc. Well, reverse engineering and shipbuilding here, of course, we have already, I have talked about it. Well, this is what that ship repair, it contains major elements of manual labor. Most encountered problem is the lack of product information in electronic form. Unless it is there in the electronic form, generation of the piece part, etc., becomes more and more difficult. So what we need, that in such cases, we need to build the virtual product model from the existing as-built object to the engineering detail level. Hence that term of reverse engineering. Here, if often we talk about digital twin, we have even gone as far as a digital twin. That means a ship is existing, I have a digital twin of that. So that something goes wrong with the actual real life ship, I have the twin here. From there, I get the geometrical and all kinds of information. This is a digital twin. So that is actually done through reverse engineering. Now, how do you do that? For the surface, at least, that is photogrammetric measurements. Techniques are used to generate as-built models of double-curved three-dimensional surfaces. Some photogrammetric, as I said, the non-contact measurement methods are needed. So the main advantage will have advanced savings in lead time, etc., that we have already talked about. So what is the takeaway from this? So what we can see that reverse engineering can play a very vital role in shipbuilding and ship repair industry. We're talking about it, but truly speaking, not that much is implemented. That is the goal here that we're discussing, and to emphasize upon that, well, this is very, I mean, it will serve a good positive purpose. So it can play a very, very vital role in both new constructions as well as in repair. So reverse engineering, now the clutch is these two, that the reverse engineering to become effective, non-contact dimensional measurement techniques have to be developed. We have photogrammetric, like I have shown the example of that ship block in Paris we have measured. That's a non-contact measurement, but to do that, we'll have to have some contacts on the hull surface. We have to make some markings on the hull surface and take photographs, and that is put in a software which does the necessary analysis and generates the virtual surface. But to do that, we have to have reference markings on the hull surface. So that itself, again, would say barrier in the process. So that's what I meant, that it has to be effective non-contact dimensional measurement techniques to be developed. And obviously adequate software for converting this measured data for surface reconstruction. We have these softwares, but well, more effective, more user-friendly, more efficient softwares could be developed in this thing. So that is what I had in my mind to share with you all. Thank you once again. Thank you very much.
Thank you, Dr. Mandal.
Thank you.
I now request Mr. Bharat Kumar Rana to start his lecture.
Good afternoon to you all. Regarding reverse engineering, I would like to present an area of crane wheel load measuring device and related equipment. This crane wheel load is a very important data for checking the design of a crane for its structure and its civil work. But now with the manufacturers, the actual load on the wheel, that data is not available because they don't measure it. Because they don't have any instrument with them. What they are doing, they have theoretical calculation. And theoretical calculation is not, it differs from the actual one. Because this theoretical calculation is based on some approximation and some assumptions. And also theoretically it cannot be done because the calculation, these formulas are statically indeterminate one. That means you cannot solve it. So you have to assume it. So in that way, the actual load on the wheel is not available to them. In some cases, their clients are also asking for actual load on the wheel because it gives so many information of the crane. For example, if wheel load is more, then more than the actual load. I mean, actual load is more than the theoretical load. That means what? You have designed it with a higher capacity. That means it is Just a minute. Okay. Next one. Next one. Next one. Next one. Next one. No, just before it. Anyway, I don't need that. So when the actual load is more than the calculated one, then the structure and civil work are to be checked for safety, because this is the actual load is more. Actual load is more than the calculated one. That means you have designed the crane with lower load. That means you have to check for its safety. When the actual load is less, when the actual load, that means measured load is less than the theoretical load, then what is happening? The structure of civil work and other design are of lower size. That means it is not cost effective. It is not cost effective, as a matter of fact. You see, then another aspect, the fatigue design. The fatigue design of the crane. It is the best way, because in many factories you will find the cranes are working maybe for last 40 years. The rail on which it is rolling or the girder are some wear out and torn out is there, but still they are running it. In that case, those positions, the fatigue inspection of those cranes are a must. There, this crane wheel load is one of the information by which we can do it. You see, there are various ways. Now we are coming to the instrument by which we will measure the crane wheel load. There are many instruments available in the market for wheel load measurement, but one of them is this load cell with strain gauges. This combination, these transducers are used. But you know, this has got some disadvantage. It needs regular calibration and it is not linear. So what we are proposing, rather from our experience, what we have seen, that we will go by this other system, right? Another system, which the transducer will be a small rail, small piece of rail, that is part of the main railways on which the crane is moving, small, say 1 meter length or so, and an LVDT transducer. So when the wheel is coming on the rail, deflection is there. That deflection will be recorded in the LVDT transducer and it will be transferred to an emitter. And it will be, what do we call, it will be recorded and some instrument will be made out of that. So this is, we can take, you know, we can take some advantage of some laboratory. Most preferable is that Kharagpur IIT laboratory. And once I did also, they can allow this type of thing. And also in Kharagpur, they have a school Name is Rajendra Mishra School of Engineering Entrepreneurship. There, they encourage the newcomers to go for this type of adventure, not adventure, the projects and do this thing. So this is all what I wanted to say. Thank you very much.
Thank you.
Thank you, Mr. Rana. I now invite the organizer, Mr. Amitabh Ghosh, to start his speech. Mr. Ghosh.
Thank you very much, gentlemen, for all the very good lectures from all the experts. I would like to summarize my points on this reverse engineering, which I'll tell you within 2-3 minutes. First of all, I thought that what is the ways of popularize reverse engineering? Using expertise from people from earlier projects, we shall be in a position to popularize and continue our effort of reverse engineering. And next is, which I have told you earlier, the senior citizen technocrats have wealth of knowledge on reverse engineering. They can be suitably, effectively, and successfully utilized. They have proven track record turnaround of existing steel plants and heavy engineering industry in India and abroad. And through this modality, we will be in a position also to solve some social problem, to engage our increasing population of techno-commercially knowledgeable senior citizens who are otherwise idle. So now, I'll give you 3 suggestions. Suggestion 1. We take this opportunity to invite all stakeholders, including senior citizens, to share their views and innovative ideas on reverse engineering. And with suitable support, we'll endeavor to process the same so that knowledge can be converted into wealth. Suggestion 2. Formation of a core group to assess various suggestions and design a roadmap for implementation of listed activities. And suggestion 3, we also take this opportunity to request INSTAC, Mr. Petition was there, to initiate efforts on reverse engineering work of public and private steel sector customers in association with Team IIT, MSME sectors, and requisite qualified and experienced technical. Thank you very much for all your great lectures. We have totally knowledge and we have gained knowledge from your lectures, but we would like to take it forward.
There should be a state forum or national forum or international forum. What you talked about.
Okay, Mr. Dey, we'll discuss it in Q&A session. So now we have heard all the lectures. I request Mr. Shubir Ranjan Ghosh to take over for interactive session and vote of thanks. Over to Mr. Ghosh. Please take over and start your.
Thank you, Alok. Am I audible?
Yes, you are fully audible.
Yes.
Okay. Good evening, all the panelists and attendees. We had seen at one point of time attendees were as high as 40. It has now come down though. I thank all the panelists who have taken pain to prepare the lectures, presentations, and give their views on reverse engineering. I think this coinage of reverse engineering has come late, and thank is due to Mr. Dey for again reviving the old word input substitution, which we had done, and probably that was the coin that we had when we started our life career in engineering, we used to do. He has done one also great favor to all of us. Those of us who has walked in and around West Bengal, probably a great many of us, we have done our life easier with the help of unknown great technicians from Howrah. I think it is definitely a demise of an industry that has taken place over time. Reverse engineering, as some people have mentioned, I could see from the net that some of the southern universities and also northern universities, they have included reverse engineering in their curriculum because they have built up labs with sophisticated 3D lasers and started. I'm not so familiar with IITs. It is possible that they may have also started. Because today the reverse engineering has become very sophisticated, and there are some people have mentioned there are legal issues, there are patent issues, and in India, since we are signatory, IP issues cannot be just overruled the way our neighboring countries had done. So this is an issue. And while mentioning this thing, I also recall what Mr. Mukherjee, Pranab Mukherjee, had talked about development of engineering in India. Definitely, Yale has been a trailblazer. But I think he must be knowing he's in the oil and gas industries for very long. With this motto in mind, PDL was created, and Dr. B.R. Chakraborty had done pioneering work in the country for development of catalyst and pilot plants. But unfortunately, there was no leadership after that, and there was no fund available to carry on those kind of projects. I have seen myself, since I was in fertilizer for a long time, I have seen myself how we throw away materials from the plant. He developed pilot plants and made it to run for development of processes. Unfortunately, those leaderships have been lost. So today we can decry, but the fact remains that we technocrats, probably administrators, are responsible for not taking up those issues. Whatever was done, somehow those efforts have floundered, and today it is a need that our young engineers who are unfortunately preferring more of white-collar jobs than the blue-collar jobs. So we have to build up these plants. We have to build up our capabilities. There are excellent people around, but it is the leadership, it is the encouragement, it is the support from the government and the institutions which are required. Unfortunately, also, though I'm not sure how Mr. Mukherjee will respond, with my humble experience of 42 years in fertilizer and petrochemical industry, I have seen the decline of engineering excellence. It is true because one way, when the software has aided in a great way in making the engineering simpler, it has also become a liability that innovation has gone to dogs. People have continuously followed the softwares without applying their mind. It has been seen in a number of cases because I am particularly field man. I have all along worked in the plant with hardware. So I know how it has declined with the quality of the people and the knowledge. They have enormous capabilities, but unfortunately, it has been all driven back to some softwares. So time has come, probably Mr. Amitav Ghosh, as he is optimistic always feels that a group can be always made and they can advise, I do not know whom and where, so can ultimately make a group where our senior engineers can, our senior citizens like us can brainstorm and give some inputs. Inputs are all around. It is the capability, it is the ownership, it is the leadership, and it is a support that is all required to take up this thing. I can thank all of you for coming for this effort. Great, many thanks goes to Mr. Ghosh for his initiative and support and single-minded approach to make it happen. I think everybody has contributed, and it's a new kind of scenario from our approaches, which they had started with power plant, energy, and gradually shifted to reverse engineering. Probably he will brainstorm and come up with some new ideas for the future, and all best wishes to him and the team that had made it possible. And thanks to the panelists, attendees once again, and good evening. Good night.
Thank you.
Thank you, Mr. Ghosh. The session is now open for question and answer. If the attendees have got any question, please, you can start now.
Just a technical thing, like whoever wants to ask any question, please press the button raise hand so that I can understand and will allow your mic to speak up.
Yeah. Okay.
I've already replied few questions online.
Okay.
So,
now, if anybody from the attendees would like to ask any question,
yeah, please raise your hand. By the time there is a question lying in Q&A section, if anyone panelist would like to answer, he can answer that Q&A section question.
Amit, I've answered one question related to the semiconductor devices.
Yeah, that's the one. Yeah, okay, I can see that has been answered now. Thank you.
Yeah.
Are the questions visible anywhere?
Yes, down below in
Q&A.
it has
in chat.
Or maybe if any panelists want to ask any other panelist a question.
Yeah, Mr. Rana was asking some question.
You find in the Q&A, the question is, you said that Atmanirbhar Bharat is our success mantra, but for most of the engineering items like electronic chips, software, electronic goods, etc., we still depend on Chinese and other European countries. So what should be our strategy to develop these items in our country and to generate revenue and jobs for others? Please answer.
Yeah. I have a raised hand, Mr. Neil. He has. Mr. Neil, you want to talk?
I think Mr. Lalit Tejwani will answer.
Mr. Neil, kindly unmute yourself and ask the question.
Thank you.
Go ahead.
Yeah, it's very good to see that so many seniors have assembled here. I think there's a lot of treasure trove information that we received. First of all, thank you for arranging this. My question is more towards, see, there are certain reverse engineering. I heard case studies of how services of ship, steel industry, all this is there. But particularly, I think where India is lacking is chemicals and specialty chemicals. You know, it's very difficult to reverse engineer, and even if we want to source them, some of them are not even available in India. So I want to put this question to the senior group here. Is there some specialized focus group or anything where we can approach for such specialized chemicals expertise? Thank you.
Anyone would like to answer this?
Was exactly Mr. Amitav Ghosh's idea that we create a kind of a database of experts, and then we can ask the industry to look at it, and then we can choose like a aggregator of expertise in the market. Mr. Ghosh?
Unmute.
Actually, it's a very unique question that chemical domain. I think chemical domain we have not.
No, what is the, excuse me, can I talk?
Yeah.
What is the item of the chemical you are thinking about?
Mostly
Huh?
electrical related. It could be insulation or casting and those kind of things where I come from.
Oh, okay.
Okay. Can I say something?
Yeah.
Yes. Amitabh.
Please.
Yes, you tell. You tell.
Yeah. Neil, actually what you have asked for is you want to get some specialized information on certain specialized chemicals and probably used in the electrical industry, the insulation composition, the insulating paste, etc. For that, what you can do to my understanding is you'll have to at least show the sample. You'll have to have the sample, right? With that, you can contact people at any of these, well, at least IIT Kharagpur I can mention, or any of the other IITs. You can contact the people in their department of first in the electrical engineering. He will be able to tell that what is this material is. If not, then he will guide you to the relevant person, and you can do all the testing of that material, find out the composition. Like one of the panelists we have, you have heard maybe that in that Durgapur projects probably that material, that suction, what do you call, impeller, the material composition you have worked out.
Banded third power station, banded.
Right. So all that that is feasible. You can initiate talks if you want. You can contact me offline through email. I can tell you whom to contact. You may get some good information.
We can connect to.
We can connect you to the right people. Yes.
I may suggest that CISR has got wings. There are several wings of CISR. They have got the research facility and developed many chemicals for the industry. It is specific chemicals that I cannot offer, but you can contact the ISR lab and you can find some answers, because electrical industry is very old in the country. So I would think that some definitely substitute would be available.
Okay. I hope this solves things now. We have another attendee, who is Mr. Partha Basista. Mr. Partha Basista, can you please unmute yourself and ask your question? Mr. Partha?
Partho
Basista. Kindly unmute yourself and ask your question.
He's still muted.
Yeah. Okay. In that case.
Yeah, he has come.
He's there, but he's still muted.
He's muted. I can't hear him.
So okay, if there is no more question, let us conclude. Yes, this.
He has provided his question in the Q&A section. He's asking, hello, my question is on EOT crane. He's asking, hello, my question is on EOT cranes, precisely lowering, going.
Actually, I have found the Partha question. Hello?
Yeah, I'm just trying to read his question in Q&A section.
You please read.
Any of the panelists can answer it.
Yes.
Yeah.
This is regarding crane.
Yeah. Mr. Ghosh, I have a meeting to attend. Can I leave? If there
Yeah, of course.
Thank you very much.
Of course.
Thank
The
you.
question is regarding crane safety.
Yeah. And anyone like to answer the question?
No. This is written. The question is on EOT crane safety, precisely on lowering of stowing and load placement in actual position in railway industry. I don't know what
Railway
is the
industry.
Yes.
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 Yeah. So I will again read back.
Question.
He's saying, hello, my question is on EOT crane safety, precisely on lowering of stowing and load placement in actual position of railway industry.
Hey, your picture has been changed, Mr. Niranjan.
No. I am just asking. I'm asking.
You are looking that as if you are sleeping.
Hello.
No, that is.
Hello, Amit.
Rotate.
Amit, there is a question from Dr. Kalyan Sen from USA. When you will include expert ladies in this sort of speakers gathering, India's superb female engineers shine in all over the world as the male engineers do.
So I think we can ask him to organize expert ladies. Mr. Singh.
Who will participate? Yes, certainly. Why not? So
she should be senior
you can
also. She
you
should
can
be
see
senior citizen also.
anyway. So
Anyway. No, but I didn't get Mr. Neeraj's number.
Now, one more question is there from Saroj Khan Singh. What are the learnings from China who have mastered the art of reverse engineering? Number one. Number two, are the core skills in reverse engineering similar or different from that needed for product innovation?
Mr. Saroj Khan Singh. He is in McNally, Bharat.
Oh, Sharoj.
Son of Mr. Srinivas Singh.
Yes. But what is the question?
What is the question? I could not see.
If you can see
you follow?
Down below, it's a Q&A section. You can Q&A section. You can see the question.
Amitoda, you take your cursor at the bottom of your screen. You see there Q&A. Click there. Then you can see. Yeah, Q&A.
There are three questions there.
Click there. There are three questions. Click there. You can see the questions.
Yeah, I got it.
Yeah.
There are two questions I can see.
There are three. Click.
What are the learnings from China who have mastered the art of reverse engineering? And what are the core skills in reverse engineering, similar or different from the needed for product innovation? So, Amitabh, would you like to answer? You see, the learnings from China who have mastered the art of reverse engineering, there are two learnings. One is good and one is bad. The good is that they have, if you talk about China's industrial espionage, it is such a massive espionage around the world that it will take a whole session to do it. Because I have two people in American universities who have been talking to me for the past 2-3 days off and on, and they were telling me that the American universities are being swamped by Chinese espionage. And it is such a sophisticated process, people, even the government of America is unable to catch it properly. The other thing is, the learnings from China is the way China can break rules ordinary countries can't. In the refinery sector, I have seen that I was talking about catalyst-based secondary and tertiary plants, where the process is very complicated. They would invariably take, for example, octane improvement in gasoline. They would take an isomerization process from somebody, from a broad European or American licensor,
they would do the first plant there. They would take all their PNIDs, process flow diagrams, all their material balance, everything. They have their own capability. So they will try to replicate that and scale it up or scale it down. This is not allowed in any other country. In India, even the government of India doesn't allow IOC to replicate another a plant which they have built in Guwahati, for example, to replicate it in Mathura. They will not. So we have, the learning from China that way is that, their systems are totally different. So we cannot, if we have to replicate, we'll have to do it within the boundaries of law, and which makes it all the more difficult. So we have to basically do a lot of R&D for that. In the oil industry, we have to do, pilot plants. We have to develop catalysts ourselves. We can take that as a guidance, whatever license we are taking, we take that as a guidance and then do an R&D ourselves. And then, so these things take a lot of effort. And just like Mr. Subir said, the present day tendency is to computerize everything, don't get into brick and mortar engineering, innovation is lacking. So we are caught in a bind that way. And the other thing is,
can I interject? We cannot follow China's model of reverse engineering. That is very sure. Because we have to have our own way. I'll tell you one example. Bullet train. Bullet train, they got technology from Germany and all exchanges of technology here and there. Then after some time, the government said that you forget about Germany and do it yourself. The engineer said that if there is accident, there is always a chance of accident. He said that we will take care. You don't have to worry. Any development job always can have accident and death. In China, a lot of accident and death takes place because of development. You don't get in the newspaper also. But this will not happen in India. This is the difference.
Exactly. This is the
difference.
Very careful. This is the difference between India and China. That our government and our system does not allow that risk taking.
Yes.
We don't break international rules the way China does.
All rules are broken. Yes, all rules are broken. Today, China is having the 75% of the bullet train network in the world.
Yes.
That was it. They're gone. There's a successful, of course, but we cannot do that. That's the difference.
I have got an experience of large scale reverse engineering. I was associated from a fertilizer plant who produces heavy water. Heavy water, definitely, as you know, is in the BRC, atomic energy chemical domain. They were making a plant adjacent to our plant with their so-called own technology. Since I was the engineering in charge from the fertilizer side, we could discover that actually very long time back, they had made a pilot plant of a heavy water plant with the German technology where the license expired. So they scaled up that particular one and built up one of the largest heavy water plant in the country without paying a single royalty, but it was actually a scaled up plant of a German technology. Very high pressure plant, very sophisticated. Those times it costed some 1,500 crores, but it was in the year of 89, 90. So this is available in the country. an expired license, probably who supplies the country that company does not exist. They scaled it up and built up a big plant.
Okay, so can I take only last question? One hand is there. After that, we can
Yeah.
wrap it up. Mr. Kalyan, I can see you have raised your hand. Can you unmute yourself and ask the question?
Yes, yes, I did. Hi, this is good morning here from US. My background is I graduated from Jadavpur in 1982, so that's 39 years. And I came to US first 5 years, master's PhD. Next 3 years, I was a professor at a university. And then 30 years, I spent mostly various Westinghouse companies. And now last 1 year, I'm running my own company. I learned for 30 years what not to do in a company, and now I'm running my own company. So my 30 years experience at Westinghouse is that I had projects all over the world, many from China, US, Europe. The Chinese, as you are discussing, and yes, Chinese people have many ways to acquire knowledge, but we in India started universities thousands of years ago. People from all over the world came to India, learned things, and went back to their country. Many Chinese did that too. This is all legal. So Indian students come to America and other countries, and they can go back too if they choose to. So acquiring knowledge from other countries is legal process. You can go to a classroom and no one asks you which country you came from. In India, my university, Jadavpur, had a lot of students from abroad. So that's one way to acquire knowledge, the latest knowledge from anywhere. Now, while we are in the working, as a working engineer, working in field, now what do we do? I can tell you from my experience dealing with Chinese companies. So our company, Westinghouse, was delivering in last decade or so for their newest power plant, 16 units that will go into 4 power plants. So the deal was that this is the way Chinese framed their contract. And it is all legal, nothing to do with what some of you are saying that they do things illegally. This is all over the table. We will build 14 units in here where I live in Pittsburgh, US, and 2 units in China. Now, do you want to take the contract? Now, other companies they approached, they didn't want to take the contract, but our company took it. And we built 14 units right here. And then while we were doing that over 3 or 4 years, the Chinese engineers were part of our team. So they learned everything that we were doing, design, everything. And then the last 2 units were built in China. We went there. I personally didn't go. I had a chance to go there for a couple of years and be liaison between the US and Chinese engineers. But this is how they do it. When they buy something of major scale.
What is the capacity of the unit?
No. This is the 4 big nuclear power plants we are talking about.
Nuclear power plant, okay.
4 large nuclear power plants. And in each plant, there will be 4 pumps. So 16 pumps out of 16, the way they made the contract, my little unit here specializing in nuclear pump, coolant pump. So they said that, okay, 14 will be built here and 2 will be built over there. And our company took it. Now, did we open up the book of what we are doing? Everything? No. What we had at that point, that's knowledge transfer. Because from that day on, what the new thing we were doing, they were separate. No one had access to that. But the management made a decision that up until that day, when the contract was signed, anything we knew, we could tell them. And because when we write the next project, everyone assumed or took it for granted that the next bid will also come from Chinese company because they just learned everything we know. But the future projects will be based on not the old knowledge, the new thing that we'll be creating from today on. That's how the division was. So there are many ways, this situation can be handled. When I go to India, and I've gone many times, every year, a couple of times, I give talks as an IEEE distinguished lecturer, and out of 150 times I have given talks around the world, half of them were in India. And I go there and I ask them, so you bought this thing from Germany or Sweden or Switzerland. Do you really know what it is? They said, no, we don't. We just bought it as a complete package. So every time something breaks, we have to depend on them. So this is not how China works. When they buy something, they make sure that the life of the project, they have a supply of spare parts, knowledge, and eventually they will build on those. That's all okay, because
But
that
to
was
check
part of the deal from the begin
contract,
with.
they are working.
So I think the way the Indian procurement works, it has to change. You cannot just buy a complete box from someone and then depend on them forever, because Indian engineers are smart. I was an engineer. I was grown up in India and graduated from engineering college. But when living in India, always we thought that, oh, someone outside is better than us, but we come here and we are the leaders.
May I interject here? You have
no,
told, I believe you have understood. It's a long years you are out. Things have changed.
Yeah,
Yes.
I know.
No,
But
actually now in the contract also, overseas contract, this transfer of technology is included there.
Yeah.
Yes,
So
absolutely.
we have started here also.
Okay, good. That's great. Great to hear that.
Yes. No. Probably as it appears, you are little not fully aware how the contracts are being done now. And what is
Actually,
also you are not maybe aware how China they do the contracts and all. Probably you are not.
No. Actually, we don't do contracts the way China does, and they have been doing it for the past 20 years or so. America has actually bankrupted itself by giving technology to China, and now America and the West are building up barriers. Everybody knows the mistake they have done. They are trying to rectify now. It is maybe too late, but this is what they have done. They have given the technology, they have given equipment, they have given capital plant. Even furniture manufacturing, Americans can't do anymore. It is the Chinese who do.
They have funded the Wuhan lab.
That is not the example we follow.
What is it? So better not to talk about all those things. Anyway.
Yeah, I think we know.
My point is,
we know China and we know USA also.
Yeah.
So, and each relationship is very unique. Relationship between USA and China cannot be compared with relationship between India and China.
Anyway. Okay. So let us conclude the program here. Thank you again for your participation, all the attendees and panelists. Thanks once again, and let us conclude here. Good night to everybody.
Good night.
Thank you.
Thank you very much.
Good night.
Thank you.
Thank you very much.
Thank you very much.
Good night. Thank you. Thank you all.
Thank you all.
Thank
Thank you, Amit.
Thank you.
Thank you.
Thanks, Amit.
Thank you.
Thank you.
Thank you, Amit.
Thank you.
Thank you.
Amit, thank you very much.
Thank you, Mr. Rajadhar.
We will continue.
you.
Definitely, yeah.
Thank you, Amit.
Thank you,
Okay.
Vanessa.
We will like to see you
Thank you.
more, even other than seminar.
Definitely.
Okay.
Bye.
We can make him a permanent host, isn't it?
He is already our permanent host.
Thank you, everybody.
Okay.